Hi again, everybody. Let's do another example for ABC. Let's do one with a little bit of trig. So let's go. Let's just do the basics. Y equals sine and y equals cosine. These obviously intersect all over the place, constantly. But let's limit it to x equals 0 to x equals pi over 2. Okay. So let's get a picture. Right. So we know sine x is basically one of these deals. Right. And so pi over 2 is going to be basically here. And then cosine is going to come down like this, right? I didn't draw that so good. But all we really care about is this region here, right? So I want the area between sine x and cosine x. Now, the reason why I wanted to pick this one is because there's two different regions, right? Or there's two regions, separate regions, I should say. There's the blue one and the red one, which the cat knocked off, which is right here. So this is a little different than when we just did basic integration and we said we want the net area, which if it was just sine x from 0 to 2 pi, the net area would have been 0. But if I want the area bound by these two curves, which is essentially what this question is asking for, that's the blue area and the red area together. It's going to be a total area. So you really have two separate problems here if you think about it. You've got a top minus bottom of cosine over sine, and then you've got all of a sudden here it switches to sine over cosine. So if you were to write these two integrals out, it would really look like this. It'd be, the area from 0 to, what's this got to be? It's got to be pi over 4, right? From 0 to pi over 4 of top, which is cosine, minus bottom, which is sine. And that would be the blue area. Then we would have to add in from pi over 4 to pi over 2, right? Because that's where they told us to stop, of the top, which is sine, minus the bottom, which is cosine. And that's really the only way we could do it for the moment. We'd have to do it separate. Now, some of you might say, but I know they're the same. It's symmetric, so I could just do one and double it. Well, that's technically true if you do know that for sure. But another little trick you could do would be to just integrate the entire region to pi over 2 of the absolute value, and then it doesn't actually matter which one you do first. Sine x minus cosine x. That will actually work too. Okay, let's do this on the calculator just to be sure. Or not just to be sure, but I already know it's right. But to show you how that it works. Okay, so let's see. Can I fit everything on the screen here? Yeah, that's probably good. All right, so let's go sine x, cosine x. And let's go from 0 to, remember my trick in class, pi over 2, but I'm going to add in like 0.001 just in case. And let's go, it can't really go less than 1 and 1, right? There. See that okay? All right, so there's no vertical line here, but that's where x equals pi over 2. So if I do, which one is cosine? That's the second one, right? So I'm going to do math 9, y2 minus y1, comma x, comma 0, comma pi over 4. That's going to be the blue region, right? Now the red region, basically the same idea, except I got to switch my y1 for my y2. Oops. I hit enter by accident. y2, comma, instead of 0 to pi over 4, it's going to be pi over 4 to pi over 2. See, that should be the 0.414 or whatever it is. Okay, because it's symmetric. So there's our point. What is that going to be? 0.818 or somewhere around there, right? But if I do the little trick here, if I do my math 9, doesn't even matter which one I do, y1 minus y2. Oops, I forgot to put the absolute value in. So I'm going to insert math, numbers, absolute value. Okay, yours might be located, you might be able to get it from the catalog, but it should be under math, numbers. Okay, and then I got to do comma x, comma 0, comma pi over 2. And that should give me the whole thing. Okay, that only works when you've got the little crisscross situation going on, where you've got the top and the bottom switching. It doesn't work if you have like a third function involved, where you just have to literally break it up into two pieces anyway. Worst case scenario, especially if you have to do it by hand, there's obviously no way to do this part by hand. So you would literally have to separate the two and do them by hand. And to be honest, this one is doable by hand. Okay, but just for the sake of time, I'm sure you could just do this by hand yourself. Hopefully your unit circle is up to speed. But that's how you would deal with one that had multiple regions. It's not net, it's total. Okay, I wanted to make sure to get an example of that in there too. Okay? All right, let me know if you have any questions on any ones that look like that, and I'll be happy to help out. All right, see you later.